Let's look at how to name aldehydes. I've shown here a generic aldehyde, and the important steps to naming aldehydes are shown below. First, you should recognize the CO carbonyl group attached to a hydrogen, as I've circled here. Another important step is to number the carbons in the chain, and you have to number in order to get the longest chain possible. Another important step is that when you're naming, it should be alphabetically ordered. So let's get right into practice problems, but first it is important that you review your carbon chain naming rules, and I have that right here for you. If there's 1 carbon, it's meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, and 8 oct. So the first aldehyde that we have right here is shown there. When you start numbering your carbons, you should start numbering at the carbon where the aldehyde begins. So that would be 1, 2, 3, 4, 5, 6, and that's your longest carbon chain. You have to recognize that there is a chlorine on there. So when you're naming it, the chlorine is attached to the 6th carbon. So you write 6 chloro, and then 6, as we showed earlier, the name is hex, and then the ending to an aldehyde is -ol, so you write hexanol. Alright, our next practice problem is this one right here. When first looking at it, it looks like a challenging problem, except that a tip to remember is that this figure right here is actually a benzaldehyde. So using that, you just have to number from the benzene group, and that would be 1, 2, 3, 4, because we number clockwise. And then in the 3rd group, there is a methoxy, and then on the 4th group, there's a hydroxy. However, because we name alphabetically, our name goes 4 hydroxy, 3 methoxy, benzaldehyde. So that is how you would name that one. Our next one is this right here. You would start by numbering from the aldehyde. So that's 1, 2, 3, 4, 5. And then to get the longest carbon chain, that would be number 6. So here we recognize that we have a hydroxy group on our 5th carbon, and that our aldehyde is right there. So we number it as 5 hydroxy, and then since there are 6 in the ring or in the chain, it's hexanol, and all is for the aldehyde. Alright, and this one right here is important to recognize that there are hydrogens on either side of this double bond. We see the benzene ring, and or also called a phenyl group. And using that phenyl group, and here is our aldehyde, there's our carbonyl carbon. So we number from there, and that would be 1, 2, 3, 4, and then the phenyl group. So when we're naming it, it's important, if you remember from your other organic classes, that E means opposite sides. I remember it by saying E is opposite, and then Z means on the same side of the double bond, and I remember that by saying same and opposite, if that helps you. So here we see that they're on opposite sides, so we name it E3-phenyl because the phenyl group is off the 3rd carbon, and this is where it starts. So 3-phenyl, 2-propanol. And the EN in the propanol is to indicate that there is a double bond right there. But another way that you could name it is E, and you often put the E's in brackets, E3-phenyl, prop, 2-enol. And this is just to show that the ene, the double bond, is off the 2nd carbon. And this just for fun, is also the chemical that is found that gives cinnamon its smell, so it's called cinnamaldehyde. And now to go backwards, you have to draw cyclopentylaldehyde. So using the tricks that we've learned, you know that it's a cyclopentyl, and pent means 5, so you have a 5-membered ring, and then you have an aldehyde coming off of it. So there is our cyclopentaldehyde, and this makes sense because if you're numbering, there's 1, there's your second carbon, and there's the cyclopentane. So the next one to name is M-nitro-benzaldehyde. And when you're naming this, it is important to remember the meanings of M, P, and O, meta, ortho, and para. So if this was your methyl group, this position would be ortho to it, this position is meta to it, and this position right here is para to it. So when we want M, that means that our nitro group needs to be in the meta position of the benzaldehyde. So from earlier, we know that a benzaldehyde is a phenyl group with an aldehyde coming off of it. And then if this is where our aldehyde starts, then meta to it would be this position right here, and you would have an NO2 nitro group. So to challenge yourself further, if you're interested, I have drawn these two structures. This one is citral, and you can try and name the IUPAC name rather than the common name. And this below is a much more challenging one. It's shown in a chair diagram, so you can change that into a ring formation. This is the common name, but you can try and name it from its IUPAC name using the rules we've shown in this video. Thank you for watching, and you can check out our other videos for more information.